Okay, I'm gonna get started now if everyone's okay with that. Hello everyone. My name is Sydney Silver and I'm the Training and Education Coordinator at COVE, and I am one of your co-presenters today for our 11th edition of the Oceans of Data Challenge kickoff. To this semester, our theme is Telling Oceans Stories. Now, before we start, one of my favorite things that we do at every kickoff is I always like to ask, which fish do you feel like today? So if you want to in chat, type out which fish you're feeling like, go ahead. I'm kind of feeling like a mix of number 9 and 5 today. Might switch to 6 by the weekend. Let's see what we've got here. We got some 5, yeah, same. 6, oh, that's cute. Everyone's happy. 2, oh, 2 is pretty good. Dwight feels like 6. Definitely 2. The goldfish with the huge eyes is definitely one of my favorite, but I think nine's my favorite. Feeling like me in the morning. 2. Awesome. DeepSense feels like 9. Yeah. This is also really a great practice too for questions. This is where all the questions will be put throughout the day. Perfect. Awesome. So before we actually start, I just wanted to do a brief land acknowledgement. I first wanted to say that we're taking, or me and the other co-founders, we're doing this in Mi'kma'ki. So I'd first like to acknowledge that we're currently located in Mi'kma'ki, the ancestral and unceded territory of the Mi'kmaq people. This territory is covered by the Treaties of Peace and Friendship, and we would first like to acknowledge that the Indigenous peoples whose land traditions we are on today, and ask that everyone take a moment of silence to consider the territory in which they are situated and our own personal responsibility in the process of reconciliation. Perfect, thank you. So I'm going to start off by giving a brief rundown of the agenda for the webinar today. I'm going to introduce the team, and then I'm going to briefly introduce the main question that will be that this challenge will be focusing around, some very brief tips and intro to what science communications is. I'm not going to go too far into it because Celia, one of our speakers, will be covering most of it. So I'm just going to go into very brief what science communication is and some brief examples to help give you some inspiration, and then we'll be moving on to introducing our speakers. So we're going to start with meeting the ocean team, challenge overview, speaker presentations. Then we're going to do an actual demonstration of the portal we'll be using. Unlike every other challenge, the main data source will be from the Oceans 3.0 portal that Dwight will be showing you how to use very briefly. Then we'll be going into our challenge details where we will describe the rules of the challenge, some of the basics of the challenge. We'll go through our challenge streams, and then we'll have a question and answer period for the challenge itself. So the Oceans of Data team. So one of the first members of the team is me. I'm from COVE. We are an innovation hub and technology park that's focusing on using and making new innovative marine tech. What that means is that we are a nonprofit that acts as a sort of support system for other companies to help them understand the ocean, make new ocean technology, or research the ocean. We do that in a few different ways. We have office spaces that people can rent out. We have a startup yard, an incubator for startup companies. We do different accelerators. One of the other things we do is workforce development, and that's my main area is doing outreach, workforce development, and helping organize challenges like this. I will now pass it on to Brogan at DeepSense to do her introduction.
Thank you, Sydney. So, hi everyone, my name is Brogan and I'm the Communications and Events Coordinator at DeepSense. DeepSense is an organization based out of the Faculty of Computer Science at Dalhousie University, and our mission is to help grow the marine economy with artificial intelligence. We leverage a unique project structure to deliver high-impact machine learning and AI-applied research projects for the ocean industry. And these research projects expose students to real-world applications of advanced technology and prepare them for success in the rapidly growing blue economy, while also enabling marine-focused businesses with advanced AI capabilities. So I will now pass it over to Morgan from ShiftKey.
Hi, I'm Morgan. I am the Events and Communications Coordinator for ShiftKey. ShiftKey is also an organization that's based in Dalhousie's Faculty of Computer Science. We're really about trying to ensure that the next generation of computer scientists and people in tech really have the skills they need to be successful. So we host a lot of events. We host events such as hackathons. We have certificates. We have a certificate reimbursement program as well. And we also have a startup incubator with ShiftKey Build. So there's a lot going on with us, and we really try to support the province the best we can.
Awesome. Thank you so much, Brogan and Morgan. So now that we've done our team introduction, I'm going to go briefly into the theme of our challenge this time. So we're taking kind of a different turn from the normal technical-based ocean challenges. Today we're doing a different kind. This challenge is called Telling Ocean Stories. And the main question that I want all of you to think about and cater your projects around is how do you present data in a way that is both accessible and meaningful? And whenever it comes to presenting data and telling stories, one thing I always think about is the term science communications, and that's going to be kind of the main theme when it comes to this challenge is science communications and how to leverage the tools it has. But first, why are we even talking about science communications when it comes to data? One of the main reasons why we focus on it and a lot of scientists find need for science communications is because of something that we call the curse of knowledge. The curse of knowledge happens to a lot of scientists and academics. I know I went through the same thing when I was doing research-focused studies. The curse of knowledge is that the more we know about something, the more difficult it is for us to see through the perspective of someone who doesn't have the same knowledge as us. So what that means is as we learn more about something and specialize about something, we find it hard to understand things from a point of view of someone who doesn't know everything we know. And that can really lead to gaps in both understanding and miscommunication. One example is when an academic is writing in a scientific journal and they want to share all that information they have. But that journal is very technical, lots of jargon is being used, and you may understand that, but that doesn't necessarily mean your neighbor, your cousin, your family will understand that. And that really limits all of that information that you have away from a general audience. And what we use science communications for is a way to bridge that gap. Science comms is an interdisciplinary field that's used to make science accessible to different audiences. And it can be used to bridge that gap, share research, stop the spread of misinformation, and help people make informed decisions. So because of this curse of knowledge, this is why we're using science communications and kind of focusing it around data. Of course, if we have our data set, we can understand it, but we want everyone else to. So we want you to focus on today and for the challenge, we want you to focus on looking at that data, taking a story from it, and then being able to convey that story to a general audience. I have some very brief tips that I always like to give when it comes to science comms. Of course, I'm not going to go too deep into this because I don't want to step on Celia's toes. A few basic ones are make sure you know your audience. So make sure you research into what audience you're presenting your data to and know who you're presenting it to. Make sure to set a very clear goal of what you want to convey. Pick your medium is really important. So you want to decide if you're going to do outreach of children, if you want to do your communications through a social media post, an article, a video, etc. You want to make sure you craft your message. So you want to make sure you know your audience, how you'll be presenting to them, etc. You want to use storytelling. So when it comes to science communications, you want to make sure you're telling a narrative with a beginning, middle, and end. And then finally, the biggest tip is avoid using jargon. I talked about this earlier when it comes to scientific articles. There's really heavy technical terms, jargon, acronyms anywhere, and not everyone is going to understand what that means. So make sure you're talking about everything in very common terms that any normal person can understand. I want to give some examples to help spark some inspiration when it comes to what you're going to use to tell your stories. Here are some of my favorite examples. You can make a fake social media account. One of my favorite science communicators is she's a Canadian named Science Sam. She did neurology, and her entire thing is posting fun, interactive media posts on Instagram, X, etc. She has a podcast, and she basically takes heavy scientific knowledge and brings it down to something that anyone can understand. Another one is a YouTube called SciShow that Hank Green hosts, and it's basically a very easy to understand show that takes information from big scientific articles, usually new and updated information, and brings it into a form that anyone can understand. That's very easy for anyone from a child to a teenager to an adult to understand. Another one I really like is a blog or website called IFL Science. It has a very similar format to BuzzFeed, where they have quizzes, articles, etc., to take fun science stories and make it into a method that anyone can understand and will want to read. Another one is an example of outreach. So taking all that information you have and the message you want to have and actually bringing it to the public and doing hands-on work. There's a lot of different ways you can do this. I put in one of the examples of what I do. One of my main things is communicating how offshore wind works and how it'll work for Nova Scotia, and communicating all of that to the people in Nova Scotia. And what I do is I work with kids. I take these little miniature turbine kits. They actually get to build the turbines. While they're doing that, they learn about the parts, how they work, get the test them, etc. So it's made a very easy and accessible way for these kids to learn about this big issue and actually use them hands-on. So these are just a few very brief examples, but I really hope they will help you when you're thinking about, okay, how do I want to tell my ocean stories? So I will pass it on to Morgan next to introduce our speakers.
Thank you, Sydney. So let's start off with our speakers. Participants, feel free to send any questions that you may have for the speakers in the chat. The next slide. So tonight we have two incredible speakers who have volunteered their time to share their experience and insights with us, and that is Celia and Dwight. So welcome, Celia and Dwight. So to begin, Celia, who is from the Royal Canadian Institute for Science, will start us off with introduction to science communication and its importance.
Thank you so much for having me. I'm really excited. I think it's really cool. So I am, so like, as they said, I have a undergraduate degree in chemistry and a master's in science communication and public engagement. I have been working with RCI Science for several years now in different capacities, as well as with the Canadian Space Agency and Science Rendezvous. And if you've never heard of RCI Science before, we are a nonprofit that's been established since like 1849, making us actually Canada's oldest scientific organization, which is really crazy to think about. We strive to connect people with science and each other in really creative and accessible ways. What started off as just lectures, traditional lectures, we now have things like cocktail classes and dog workshops and trivia nights, nature walks, screenings, anything and everything we can think of. We really hope to meet people where they're at and build science culture within Canada. So if you're curious about that, I can give you more information later. But yeah, Sydney did a really great overview of what science communication kind of is and why you should do it. And I also want to, affirm what she's saying about, science communication can look like a lot of different things. It doesn't just have to be a blog post or social media post. There's so many ways to do that. And, while I'm explaining this, I'd encourage you to go to the Slido so that we can be interactive in the next slide. But science communication, depending on who you talk to, they might have different definitions. For the sake of my presentation, I'm going to define it as any time that you're trying to connect people with science, and these people may not have specialist knowledge in your specific field. Every scientist has, their own field that they are very knowledgeable about, but may not be able to talk in the technical terms with other scientists if they're in different fields. As you can see, this is called a public engagement onion. If you go sort of towards the right side, it's more about just conveying information. It's very one way. Whereas if you move towards the inner circle, it's more dialogic. It's two-way, multi-way. You get to the point where you're actually involving who you would have traditionally thought of as your audience, as people who are co-creating knowledge with you, co-creating research. They're part of the research process from the beginning to the end, and not just as end users. But there's so many things that you could, do with science communication, and this is not even comprehensive as much as it is a very full graph with lots of tiny text. But I encourage you to sort of look up this public engagement onion and see what else there is, and for inspiration for your own ways of telling ocean stories. Since it is a storytelling kind of focus for your challenge, I do want to kind of take us a little bit back to storytelling and what, like English class, what are some elements of a story? Can you share like a word or a couple of words of, what makes a story a story? Challenge. Yes, there's some sort of challenge that you're trying to overcome in the story. Absolutely. Hero. Yeah, there's a character, there's a hero, main person, there's a narrative arc. Absolutely. I think someone tried to put hero's journey. Yep, absolutely. A lesson. A resolution. Okay, yeah, those like plot points. What about like other than plot, what else do you need for a story to be a story? These are kind of more like, yes, you need characters. What else do you need? A setting. Yeah, exactly. This is like deep into elementary school, isn't it? Settings, characters, you know, anything else? Sorry, I have a dog. um, okay, yeah, beginning, middle, end, narrative arc. Something else. Okay. Timeline, yes, time. So, I mean, all of these elements of a story can be kind of boiled down to who, what, when, where, and why, right? So who we're talking about are characters. Who is going to be the main character? There are multiple people involved often in research. So like, are you going to pick a couple, one? Whose point of view are you going to connect with? And then I want to kind of take it also on a meta level of when you're crafting your story, who are you trying to engage? Just like Sydney was saying, you need to be really specific. The more specific you are with your audience, the more impactful your story can be. So I know, like, I've been tempted to do like general public, but even within that, there are so many different kinds of publics. What are their interests? What are their demographics? How do they feel about science? Are they already interested? Are you just like looking out for the science nerds, or do you want to reach people who maybe are on the fence? So all of those things will depend, and will change how you're going to approach your story. Then of course you have your what is your science? And from there, what is the plot going to be from that science that you're trying to share? And then you've got your setting, as people mentioned in the word cloud. In terms of, as a science communicator, the where is also, where are your audience? Where are they at? Where can you meet them? Whether that be metaphorically, like where are they at with the science and how they feel about it, or it's like where they are actually, engaging with information already. Is it social media? Is it at a coffee shop? Are they on your campus? Things like that. Those are going to be important part of crafting your story. Then when, I mean, pretty straightforward, when it happens, when your science research is happening, for example. But then the other thing to think about is the story going to be timely for your audience? Sometimes things might be outdated or may not feel as important as other stories. But sometimes, stories come back. Like you hear myths come back from like years and years ago that people kind of forgot about, and it comes back again, and then it becomes timely again. So those are things to consider as well. And then the last big question I would say for your story is the why. So I want to pass this off to you now that I've talked at you a bit. Why do you want to tell science stories? one word answers as well. Just, it might be a pretty big, broad question, but what are your goals for sharing your science story? Misinformation, that's a big one. Yes. Yes, connecting research to community, absolutely. Spreading knowledge, yeah. Absolutely. There is like an advocacy part of science communication that a lot of people feel. Passion, yeah, that is just as important too. You need to be passionate about SciComm in order to do it. Like, just enjoy spreading information. Okay, yeah, spreading information. Sorry, I thought I said the wrong thing. But spreading information, inspiring change, like youth outreach is often that, or even just changing people's behaviors based on science. All of those things are important, and I love these answers. There is no best answer. There is no moral value to each of these answers, except that it shouldn't be about you. It's about the people. It's about your audience and what they have to gain from this, right? And especially with oceans, I'm sure inspiring change is a huge part of it. Yeah, overcoming hopelessness. I love that answer actually, and you've really like hit one of the themes that will be in this presentation. Great, so I'm going to move on to why, now that you've kind of mostly answered it for me, which is great. But the other side of it is also, why should people be interested? You can't assume that people are interested just because it's true, just because it's science, just because you think it's interesting. You need to think about what's in it for them in this story. And that could be part of the conflict in your plot. That could be the hook, how you get people listening. So it's really important to think about why from your audience's perspective, which leads me to say this very controversial thing. Great science, unfortunately, does not speak for itself. That's why we need science communication. Science communication and science stories help bring out why the science is great. Because, as Sydney said, like if you're reading a journal and it's in technical terms, if you don't have any expertise, it doesn't really make sense. It doesn't really highlight the broader context of where this article and research is coming from. So we really need these stories to also help contextualize it and help it make it more accessible. So, this who, what, where, when, why, these are all like the premises of your stories. And also as a science communicator, I'm getting a little bit abstract now, but it all, it gets categorized into your purpose of your SciComm, the people that you're reaching, and the science that you're communicating. And all of these three work together to inform your methodology. This is your how you're going to tell your story and how you're going to frame it. So you need to think very intentionally about all of these three things. And if I haven't said it enough, throughout this whole thing, you're putting your audience first. And I should make a note about the ethics of being a science communicator. You need to be really considering the choices you're making in terms of your narrative techniques, the examples that you're using, and if they're articulating what you're trying to convey clearly, and what you're deciding to omit from your story as well. And is this a story that you should be sharing? Are you the right storyteller for it? Is this your story to tell? All of those things are at play, and especially with the focus of how your audience is going to receive it, right? Sometimes, like, I'm sure you've had in your relationships where you will say something and they'll totally misinterpret what you were trying to say, and that's part of the whole process for science communication. Is if it can be easily misinterpreted, so we really need to think of it from our audience's perspective. And since you're talking about oceans, climate change is probably going to come up, and I should note, framing again is super important. That means how you're presenting your information through specific values, symbols, metaphors, analogies, all of those things. Those are intentional choices to make sure that what you're saying is coming through very clearly. So that's framing. And then the other side of it is that through climate change communication research, which is a real field, we are learning that when we focus, at least in North America, when we focus our values on protection, so protecting the earth, protecting lives on earth, and when we're focusing on the value of responsible management, those climate stories are really effective. Of course, we all come from different cultural mindsets and different values. If you use other values, they become less impactful. More broadly, these two are the ones that really hit home harder for people, even across the divide, which is really interesting research. when, you know, climate denial is huge, and it's very difficult, challenging issue to address within communications. Okay, so now you have all your stories, your story premise. How are you going to actually craft the narrative? I wanted to share an example, and I don't think you'll be able to hear the audio, but there are captions, so hopefully maybe we'll start with this and I'll skip the other videos during this. But this is one of my favorite science stories ever, and since Sydney mentioned SciShow, before, when this came out, he was just, you know, on TikTok, and now he is on the SciShow as one of the co-hosts. So you never know where your story can take you. Hopefully
I did my thesis on time perception, and I learned my favorite science story ever, which is how we learned that bees can perceive time. The experiment is pretty straightforward. A scientist put sugar water outside of a bee's hive every day at 4 p.m., and soon enough, the bees learn to leave the hive every day at 4 p.m., even when there's no sugar water. Therefore, these bees must be measuring and perceiving. Oh, hold your horses. What if the bees are just doing something else, like measuring the angle of the sun? So they did the experiment, again, in the dark this time, and the bees still come out at 4 p.m. Therefore, bees, well, hold on, what if they're measuring the heat from the sun instead? These back and forths kept happening until they ended up recreating the experiment underground in a salt mine. And still, people were like, what if they're measuring the rotation of the Earth? How do we prove that bees perceive time? Until one scientist did the exact same experiment, not in a salt mine, but in Paris, and then flew the bees to New York City, where they left the hive at 10 in the morning because they had jet lag, because bees perceive time.
So yeah, I always love that story. Every time I see it again, I think, wow, that's a great story. Sorry about my dog. But hopefully that kind of gives you some inspiration about what it looks like to craft a really impactful story. And it follows a very traditional, like, arc of a story, but I also want to challenge you again to be creative, because there's so many ways that a story can take shape, can take form. I'm not going to go through any of these necessarily, but I encourage you to look through what other story arcs exist, be creative with them, and the perspectives that you choose to take. Maybe it's easy to take the perspective of a scientist, but maybe there's someone else in the story that you can take the perspective of. Does it have to be a chronological timeline? There's a story I'm going to share at the end of someone who decides to not do a chronological timeline, and it turns out very, very inspiring and amazing. So now we're going to go into sort of like the template that you would follow. This is, again, traditional storytelling. You can change things up as you go, but this helps you kind of outline what you're looking for. So the first bar I'm showing is kind of like where you would put, you know, the bullet points that you would say in text or in verbal format or wherever it is. And then your visual cues is the kind of the second bar that you're thinking of like what is going to complement my message, what is going to highlight things or make things clearer. This is just a template. It's just to help guide you, but you don't have to use it, but it might be helpful. So, you know, the first thing you start with is your hook. With social media these days, we have like 3 seconds before we start to tune things out. And even then, just because they've stayed after your hook, I would say, like, you need to keep thinking about what will still continue hooking people in, because they're just gonna, at any point they can leave. They're not obligated to listen to your whole story. So you need to think about at each plot point, at each story beat, what is in it for them? Why should they stay? Then you're going to set the stage after the hook. This is sort of like your who, what, where, when, whys, setting the context and the premise. There's a catalyst, maybe. That's when your story begins. There's a conflict, climax. Again, you can have multiple of these. You can have them all be the same thing or separate things. You just have to think through what that looks like for your story. But the big thing that you're going to end on is your conclusion, because like if you've all seen a movie or read a book where we're so excited for the end comes and it's disappointing and it's ruined the rest of the story. This is part of it. Your sci-com needs to have a good way to end that's not just like, here you go. What do you want your audience to get out of your story? What do you want them to do with this information now that they have it? So is it a call to action? You want them to do something? Is it a new perspective? You want to encourage them to stay skeptical about information? Are you sharing resources so that they can learn more? And then especially with climate communications, it's always important to end with, what do we do? Because like it's a huge thing that we have to work on. And on top of that, not just focusing on individual actions, but also what we do as a community, because I'm sure we've all been there where we feel like we're just, not, pardon my pun, but we're just a drop in the ocean. What can I do as an individual that will actually make a difference for the climate crisis? So really focusing on a community-based approach in your kind of wrap up is important. I had another thing that I wanted to share from the Monterey Bay Aquarium, but we can skip that and I can share that later if you're interested in what I was about to share. But I guess I was going to ask what made the story stick out to you, but I guess what made that bee story stick out to you? What are elements of it? Again, one word answers. What was it about that story that was compelling for you? That was a turning point for you? Why are you going to remember it? What made it good for you? Or maybe it wasn't good for you. Dramatic. Yes, it was dramatic. Good. It's just dramatic. Presenting in the dark. Yeah, like it was like oh, all of a sudden there's no person on screen anymore. Anticipated questions. Yeah, there's like you're ready for the next thing. Quick cuts. Yep, you're keeping people engaged, you're keeping their attention, keeping them on their toes. Absolutely. His speaking was engaging. Yep. Great. Yeah, those are awesome. And those are great things to keep in mind when you're writing your stories. Humor, absolutely. Suspense. Yes. These are amazing answers. Thank you. Yeah, keep these in mind as you're writing or crafting your story. So I'm just going to end on this one thing about making your science stories sticky, making it stick out, because misinformation, myths, as you guys mentioned, that are important to you, they are sticky. So how do we unstick them and restick accurate information? There's a great acronym to making things successful called SUCCESS that will help you. So S stands for simple, like Sydney said, like avoid jargon. Only use it if it's going to come up again and it's going to be too cumbersome to not use it. The fewer the syllables, the better. Use analogies. If you're using data, for example, do you need everything in the graph to share your story? Maybe you just need to highlight certain things. Do you need all of the numbers? You really just keep it as simple and as critical information as you need. Unexpected, that's something that you were all mentioning before about like suspense and like the shock value, the drama of it. The unexpected is very helpful. Things like, it doesn't have to be like super dramatic, but even like key facts that wow people. Credible is another important thing. It's finding that fine balance of providing just enough information without being too overwhelming, which I might be right now, apologies, but providing just enough information also to like cover any knowledge gaps. Once there is a knowledge gap, we might be tempted to fill it with something, and it might not always be accurate because, you know, we inherently don't really like uncertainty. We don't like knowledge gaps. So try to make those logical steps as much as possible with, you know, while keeping it simple. So it's a really fine balance. Concrete, making your story very concrete is important. So not just like fact dumping without being intentional about what you're sharing, or just correcting mistakes. You need to really strategically frame what the new accurate information is, really contextualize it, use analogies, and that helps make your information concrete and like easily intuitive, I guess. The next thing is people might think of science as unemotional, but we do need to be emotional. A lot of people have an emotional reason for being a scientist, so feel free to bring that out. People may not always remember what you say, but they'll remember how you say it and how you made them feel. And especially this is important with climate communications. Ending on a note of fear or sadness is not good. Having a sense of a crisis can actually really backfire because people feel hopeless and then they're like, what's even the point? But what really works in climate communications is hope. So giving them a sense of hope. And then again, stories always make things sticky. Thinking about narrative techniques, things like sensory language, rich descriptions, vivid verbs, alliteration, personification, analogies, all of those things that you learn in English class. They're helpful. They'll come in handy. This was a story. I encourage you to go look at it. Story Collider, Emily Darling. She's amazing. The story is just so good. It starts off, you're like, I'm so sad, but it ends really, really hopeful. So I encourage you to go see it. And yeah, that's all I have. If you have any questions as well after this, feel free to email me. RCI Science, once we have our new website up, we will have a membership. We will have a learning module called Foundations, and you can also follow us at RCI to see what's up. And we also do, one-on-one coaching and tailored workshops. So yes, feel free to reach out. I would be excited to hear from you.
Thank you so much, Celia. Morgan, you can go ahead.
Thank you so much, Celia, as well. Dwight from Ocean Networks Canada will now introduce his organization and demonstrate the Oceans 3.0 data portal. So welcome, Dwight.
Great, thank you. And Celia, I love your presentation. I took some screen grabs. I put something on my to-do list, and I really enjoyed everything you presented. So stories are where it's at. And so I hope everyone here and people who are listening to the recording will get some ideas for data stories from my presentation. And so somebody, Morgan or someone, just remind me how much time I can spend doing this. I'm going to start a timer.
30 to 40 minutes for both parts.
Okay, sounds good. All right, let me share my screen. And let me do this. Okay, and is it showing up? Ocean of Data Challenge? Great. All right, so as mentioned, I'm Dwight Owens with Ocean Networks Canada, and I want to acknowledge with respect that I live and work in the homelands of the Lekwungen peoples, and including the Songhees, the Esquimalt, and the Wasanich peoples, whose historical relationships with the land and the ocean continue to this day. And today I'm speaking to you from Bellevue, Washington, which is the traditional homeland of the Duwamish, the Suquamish, the Muckleshoot, and the Snoqualmie Indian nations. So, and I'm very fortunate and happy to be here as well. So today I wanted to give a super brief overview of Ocean Networks Canada and a super brief overview of Oceans 3.0, and then spend most of my time sharing some data story snapshots so you can get ideas for the stories that you want to create. And I'll share a little bit about data products, data processing options that are available to you. And then there'll be some Q&A time as well. So I work for Ocean Networks Canada. We are a national scale facility. We operate ocean observing systems in the Pacific, in the Arctic, in the Atlantic. And just last year, we installed our first system off the coast of Antarctica. And we also do a lot of data management. So we have this map kind of shows the breadth of our installations in different locations. We've got lots of data and installations on the south coast of BC. And here on this map, you can see Vancouver Island, Victoria, where I live over here. We've got different observing systems. This is Vancouver and the mainland over here. We also have data from the north coast of BC, Prince Rupert, Kitimat, Manila Island, Hartley Bay, other places. And then in the Arctic, we have data from many locations, and we have a long-running underwater observing platform in Cambridge Bay in the Kitikmeot region, and I'll show you some of that. And we have partnerships with Memorial University of Newfoundland and Labrador, as well as with Dalhousie. And so we're collecting data and distributing and sharing data through those partnerships. Then a big part of what we do is build and extend and maintain the Oceans 3.0 data management system, which manages all of our infrastructure, the data acquisition, the instrument command and control. We have a data center, a data archive. We do all the data enrichment. We have a portal, and that's what I'll be showing you today with different applications for browsing the data and seeing the analytics, the visualizations that are generated through this system. And just a sense of the scope. So we've got around 12,000 active sensors producing data right now, over 600 instruments, and we're pre-generating over 10,000 plots every day. I'll show you some of those. And we're handling an incoming 10,000 plus data requests, archiving 400 plus gigs, and our total data archive is over 1.7 petabytes at this time. So some of the main software tools, and you'll see a couple of these today, include the data preview. This is for looking at snapshots, those 10,000 pre-generated plots. The C2 Pro, which is our application for looking at video from cameras that are at the seafloor. And C2V3 for looking at data video coming from remotely operated vehicles when we go diving in different areas. Hydrophone viewer for looking at spectrograms created from hydrophones. We have a pretty big hydrophone data array. And dashboards is an application for integrating data from different sources or different types onto a single web page. Data search, which is our flagship application for browsing and specifying and requesting and downloading data through the web. Plotting utility is our application for visualizing scalar data, so numbers over time series on a graph, and you'll see that today. And we have our open API, which allows you to discover the locations, the devices, the deployments, the properties, and make data requests, and then formulate your queries that you can use directly in your code to pull data into whatever application you're working on. So we have a bunch of resources. I'm just going to show these and copy them all into the chat. So one sec here. Oops. Wow, I hit the wrong thing. And let me just grab that. And the reason I'm doing this is because I won't have time. Oh, you know, okay, I can only share to the hosts and panelists. So maybe one of you can share to everyone else. So I've dropped that in the chat. And I won't be able to show all this stuff today, but you can go back and you can explore Oceans 3, you can register for an account, you can look at the web pages, you can look at these demo sessions, and they will show you how to use all the different applications, and you can see the maps of our locations. So I hope those can be copied into the chat for everyone to see. And I'll just go on, and I want to introduce a series of data story snapshots for you. Different types of data and different locations that you could explore. And we're going to start in the Arctic. So we have data from different places, but we're going to focus here on Cambridge Bay, which is on the south side of Victoria Island in the Kitikmeot region. And I'm going to come in here and let me stop share. So we have different themes for this challenge. And one of the themes is called Above the Water. And so what I'm going to do here, this is the Oceans 3.0 data portal, data.oceannetworks.ca. And I'm going to come to the preview. So here's our data preview tool. And we have a geographic browsing tree on the left. I'm going to come into the Arctic, into Cambridge Bay. We have a shore station and underwater station. So the shore station, we have a meteorological station there. And we could go ahead and look at the temperature, like how cold is it in Cambridge Bay today or yesterday? And so this is showing the past 24 hours. There was a high of, looks like about -16, and it dropped down below -28. So it's been getting cold in Cambridge Bay. We can also look at the past 30 days here. And here you can see the variations down to nearly -35, up as high as maybe -14. So you may want to create a story characterizing the weather in Cambridge Bay. And you can look at the full time series. I'm going to click on this station summary here. And we've got all the different parameters, but I'll just choose one of these, the air temperature view in the plotting utility. And it's going to load up the air temperature from Cambridge Bay. And we first installed our system back in 2013 in August. So we have coming up on 12 years of data. So if you scroll over this, you can see, the high temperatures. This is 19 degrees here, or even it gets into the 20s sometimes. I think this was 23. And low temperatures, -39. I think I saw some -40s. So you can look at the whole range of temperatures and other weather parameters in Cambridge Bay, and maybe you could write a story about that. Another really interesting instrument we have here, I'm going to close up this shore station. Let's go underwater. And
Dwight, sorry to interrupt, but none of us can see your screen.
what? Oh, I wish you had interrupted me earlier. Okay.
I was like, was he supposed to be sharing a screen?
Oh, darn. I'm so sorry about that.
Oh, that's fine.
Okay, next time if I do that again, please tell me.
Yeah. There, you're good now.
Okay, so you missed the whole thing of how I got here, but I'm going to just roll over the screen and show you these temperatures. We've got -20 or +20s, and we've got -40s. So this is the whole range of temperatures. And I got here from looking at this, where is it? Data preview, clicking this link, view in plotting utility. And before that, I was showing, sorry about all that. I was showing the air temperature just over the past day. And here you go. This is just the past day of temperature in Cambridge Bay. So let's go underwater. So that was above the water. Underwater, let's look at this ice profiler. And we have this one measurement called ice draft corrected. And so this is looking at the thickness of the ice. And so this is the past day. You can see the ice is 1.2 and growing up to 1.12, 1.3, 1.14 meters in thickness. And if I come back to the plotting utility, we can come to the same thing, ice profiler and the ice draft. And this is going to pull the full time series of the ice in Cambridge Bay. So give it a minute. It's going all the way back to 2012 when we first installed our ice thickness instrument. And here you can see the growth of the ice. So it starts here this is October 19th, and then it's getting up to almost 2 meters, and then it melts, and it's gone by July 25th. And the same kind of pattern. But you could look at these variations in the thickness. What's going on there? You can see that there are some data gaps. So our instrument died a few times, or the connection died. And so there's very interesting patterns. For example, here, why did the ice get higher? And then why did it get less high? Why did it shrink? That would be a really interesting thing to look at. And one thing that I did is let me just come back to my presentation. I did a plot of the freeze up dates in October. So on the left, these are the dates of October when the ice first was measurably thick. And I plotted them across the years. And I added a trend line, and it appears that the freeze up dates are getting later. So is this a real thing? Is this a climate signal? That might be interesting. I just did a very simple analysis. Maybe you can do something different. Another thing that would be pretty neat to look at, and let me just stop here. You can come down to the oxygen sensor. So this is underwater. We have oxygen concentration. So it's pulling up the time series of oxygen data here. Give it a moment. And we still have the time series for the air temperature and the ice draft. It will redraw all of these plots so you can compare them. And here's the oxygen plot. Let me just expand it a little bit. Let's see. So you can see this pattern where the oxygen is going down. This is October. It's reaching a minimum in March, and then it's going up. Here's a minimum in late February, and then the oxygen's going up. But late February, the ice is still there. If you look back here, the late February, the ice is still growing. So why is oxygen taking off before the ice melts? You can see it reaches a maximum here in July. So how does that relate to the melting of the ice? What's this pattern all about? What's happening here? That would be an interesting story to share. Okay, now we're going to go to a different place. And this is on the west coast of BC. And over here on the right, this is Vancouver. This is Vancouver Island. These are the Gulf Islands. This is the Strait of Georgia. We have different observatories here. We also have radar systems here. So lots of interesting data to look at. And one of them is our coastal radar system. So I'll show you how to view that. We come to data preview, and I'll come here to the Salish Sea, Strait of Georgia CODAR system, coastal radar, oceanographic radar system. And now it's going to load up yesterday's pattern of surface currents, the current's magnitude and direction. And so you can look at these. You can also look for the past month, or you can pull up for any time over our whole history of data from these places. We have similar systems in the north coast of BC, Hecate Strait. In the Hecate Strait, we have two radars looking across from the mainland over to Haida Gwaii, and we can look at the patterns of currents there. So that would be really interesting. And there's another one in the Atlantic. Off the coast of Nova Scotia, we have the Nova Scotia CODAR system. And there are two radars, one here, one here. And we can look offshore and see these patterns and animations of surface currents. So you may be able to tell an interesting story about these currents. Maybe you could look up at a time during this past winter when there was a big storm and look at what happened to the currents. Okay, so while we're here in this system, let's look at a different kind of plot. And we're going to go back to the Strait of Georgia. And this time we're going to the Strait of Georgia East within the Venus network. And there's an echo sounder. So this is what we call our bioacoustic sounder. And the bioacoustic sounder is a device that measures acoustic backscatter as a proxy for detecting zooplankton, fish, bubbles, and other particles in the water column. So it has transducers, 3 of them. So this one's at 38 kilohertz, this one's at 120, this is at 200. And they're looking from the bottom. So the depth is over here, 163 meters. And they're looking up to the surface. So the surface is where that red line is. Above the red line is nothing. And this is over 24 hours. So this is late afternoon, dusk. This is the nighttime, back to dawn and the daytime. And we can look at these patterns. So what is this red stuff here at about 120 meters during the middle of the night? What's going on there? And what are these patterns, these movements? Are they zooplankton? Are they zooplankton who are hiding during the daytime? It would be really interesting to try and understand one of these displays and create a story. We have another one of these. If we come to the Northeast Pacific Ocean, into Barkley Sound, Folger Passage, Folger Deep, there's an echo sounder here. And this is a little bit shallower. It's at 94 meters, but it's the same type of data, but very different patterns. Maybe you could compare the patterns you see at these 2 different echo sounders for your data story. Okay, so I'm just going to remind you where we are. I was talking about Folger. So this is Vancouver Island off the coast. The Strait of George is over here. Vancouver's over here. So we're going to zoom in a little bit more on Folger Passage. And we have that station at 100 meters, and we have a cable that's coming up on top of this reef at about 25 meters depth. And November 20th, 2024, there was what we call the bomb cyclone. It was a very rapidly deepening cyclonic storm system off the coast, and it had big impacts on the West Coast. So here's some data. This is from an acoustic Doppler current profiler from the top of that reef, so 25 meters depth. So you can see the depth here. And this zero line, that's the water surface. Ignore what's above it. And we're going along here, and what happened? It looks like the water surface is now on the bottom. So something very drastic happened. And if we look in the other data from this instrument, this is the velocities. So the red ones here, this is the east. So very bright red would be strong east, and bright blue is strong west. So you can see very strong westward currents. And then it kind of became more eastward. And this is the north-south. So dark red is very strong north. You can see very strong northward current velocities. And then it just completely changed. So what's going on here? So here's some data. I'm going to, maybe I'll just show it here. No, I'm going to actually show you how I have saved this. So within my plotting utility, I have some safe plots. And you can do this too. And I have one called the bomb cyclone at Folger, 20 November 2024. So now it's going to generate a couple plots. Let's look at the bottom one. So this yellow line, this is the pitch, and the black line here is the roll. So you can see the pitch and roll of this instrument completely changed. And this one here is the turbidity. That's the black line, and gray, the gray bars, and the yellow line is the temperature. And you can see that the turbidity was kind of mixed. Then it became pretty low, pretty clear. And then the temperature dropped, the turbidity went way up, and it just spiked at the top of the scale. And the temperature stayed low. So that's a very interesting event. I'll give you some more clues. So this is the camera's view of that platform. You can see the 80CP instrument right here. And then afterwards, it looked like this. The 80CP instrument is completely gone and the water has become very cloudy. And at the same time, we were measuring currents. And here we can see currents of almost 3.5 meters per second. So very powerful event. And we have, in our camera, we were watching this octopus. And the octopus was getting just beat around by these very strong currents. And just grabbing with all of its tentacles to try and hold on. You can see it flapping. And there it just got turned around the other direction. It's like it's in a strong windstorm. So that might be a fun story to tell. Here's a different story. This is Clayoquot Slope. It's also off the west coast of Vancouver Island. And we dove with our remotely operated vehicle to a place at about 1,260 meters. And we were watching these crabs. And there was methane bubbling out of the seafloor. So naturally occurring methane. And that crab just suddenly took off. And it floated upside down. Something came off of it, and it's got its head covered with mud. So that was a very interesting event. And in fact, there's a scientific paper about this, flipping for food. So you could look at a scientific paper and maybe you could develop a story about the data and about what happened in this very unusual event. Now we're going to go to a very different place over back on the East Coast. And we're going to use this thing called the Community Fishers Map. So I'm going to come in here and let me just switch. So this is our Community Fishers Map. And let me go to the calendar. And I'm just going to choose more recent ones. So let's look at things since September 2024. And you can see we have two bullseyes of data, one here in Nunatsiavut and the northern Labrador coast, and another in Newfoundland. So what's in these bullseyes? Well, let me just zoom in and zoom in again. And you can see all of these little markers. And each of these is a vertical cast. So this is going from the surface down to about 55 meters. This is temperature, this is salinity, this is chlorophyll, this is oxygen. And this was taken in October 3rd, 2024. So there's a profile here, but we could look at one over here, closer to the end of the inlet. And it's not as deep a cast. It has some patterns that are similar, some that are different. We have some that are more offshore here. So it may be really interesting to look at these vertical casts that were gathered by people living here in Nunatsiavut and compare them with the vertical casts down here in this inlet of Newfoundland. So here's one. This is from December 5th. And the temperature was quite cold at the surface, 0, but then it warmed up to over 6 degrees. Very different kind of profile. So this might be a really interesting data story for you to do to compare these vertical casts and what's happening in the water column in these two locations of the Atlantic. Okay, Now we're going to go way offshore in the Pacific. And this is at the spreading ridge boundary between the Pacific tectonic plate on this side and the Juan de Fuca tectonic plate on this side. And there's a rift valley in between here. And this is a super interesting location. So I'm going to just switch, come back to my data preview. And if we go into, the name of this place is called Endeavor. And let's just go to Endeavor East. And in the conductivity temperature depth, let's just look at the temperature from the past 24 hours. And you can see it's about 1.81 to 1.82 degrees. These are the temperature variations over the past 24 hours. And we can also look over the past month. And, you know, it's in this 1.8 range. So it's pretty cold. But what if we go to look at a different place? Let's go to the main Endeavor field. There's a water sampler here. Let's look at temperature here. And temperatures are much warmer. It's 10 up to 12 degrees here. So why is it so much warmer here than at the other place? They're not very far away. They're both quite deep. This is 2,184 meters. So that's a very curious thing. Now, if we look in our C-Tube, which is our application for viewing video from underwater cameras, this is a zoomed in view with a 4K camera, and you can see there's a sea spider here crawling. There's a vent whelk. These are tube worms. We can see in very high detail. And this is an ecosystem that lives in the warm waters of these hydrothermal vents in the deep, deep, deep ocean. So here you can see the whole ecosystem. So that may be a really interesting thing to do your story about, this ecosystem, what it looks like, and what kind of animals live there. Or you might be interested in looking at the temperature. So let's go here to, let me come back to the data preview. And this time I'm going to go to, main Endeavor field south. And there's an instrument here called the benthic and resistivity sensors. And I'm going to choose corrected temperature here. And you can see the temperature is 303 degrees. So it's much, much warmer. And these temperatures are from these vents that create these hydrothermal towers that can be tens of meters tall. And here's a remotely operated vehicle down there. Here's one of the hot smokers with the superheated fluids that are laced with minerals that forms these towers. This is a colony of tube worms that thrive in this environment. So let me come back to my plotting utility. And I'm going to choose a different thing, bars variation at main Endeavor field 2024. So this is my own safe plot. You can make your own safe plots if you create an account. And I could also share this plot if you want it from me. So I'm just going to expand this a little bit. Oops. And so what do we see? We see the temperature here is around, what is it, 30 degrees. And then it rose steadily all the way up to 386 degrees. Then the temperature went down and down and down and down to 20 degrees. Then there's nothing. Then it came back and it's kind of wiggling around here from 6 degrees to 30 degrees. Then it came all the way back up here to 154 degrees. And then it died. If I click here, you can see this was our bars number 2. And that instrument completely died, and we replaced it with, right here, I'll click. This is bars number 4, a new instrument. And when we placed that instrument, the temperature started out down here at almost just 1 or 2 degrees. And then it shot up to 345 degrees. It was steady for a while. Then it got even warmer, and then it died. So what happened there? That would be a really interesting story. And you can learn about this by watching the dive where we went to replace the instrument. Let me just show that. So this was the instrument here. And you can see how it's all covered with stuff. And also, let's see, this is when they were removing the,
What is that?
there's the connector. And this is when they were, once this comes up, that's the probe that was in the vent, and they were removing it.
First time we've ever been able to slowly remove one. I feel like usually they just fall out when you're trying to break.
So there's a little mute and unmute, and you can listen to what people were saying as they were operating the vehicle on this particular dive, and you can learn about it and create a story. So then I'm just going to show you one last thing. How are we doing on time? 35 minutes. So can I go a couple more minutes? Is it okay?
Yes, for sure.
Okay, so I'll show you one more thing. We have at the same place, this Rift Valley in the that we've just been looking at, we have this Endeavour earthquake catalog. And you can see this map of earthquakes and the depth of these earthquakes, the magnitude, they're very small, 0.6, 1.1, 0.3. But if I come over here, we can zoom in and we can see a bazillion of earthquakes. And so all of these data are available. You could explore the data and you could try to understand what's happening with all these earthquakes. And I'll just let you know, there's interest, a lot of interest in the scientific community that we may have a lava spreading event in this location sometime this year. And so that would be a super interesting event whenever it happens. We don't know for sure when. Okay, let me just go back to the boring stuff. So data products. We have many, many different types of data products that are available, different formats, MATLAB, NetCDF, CSV, audio, video, and they're generated by Java or by MATLAB, generated on demand or pre-generated. Some are scalar, some are complex, some are combined. And when you're choosing data, you can choose different options for cleaning the data, averaging it, choosing minima, maxima, standard deviations, detiding, that means removing the title signature in the data, other special options. So over in this little screen grab, you can see I was choosing clean data. I'm switching the averaging from 1 minute to 1 day and to not fill gaps. And this would be for choosing a MATLAB file. So you can have many options for accessing data in the format that you like and that's familiar for you. Okay, so once again, we have all of these links, and were these shared in the chat already? Whoops.
Yeah, they're in the chat.
Okay. And hold on a sec. Yeah, okay, so I don't need to re-paste them.
No, you're good.
Okay. All right, good. So you can access all of those. We also have a Science Hub, community.oceannetworks.ca. You can go there and register to join the Science Hub, and probably I'll be the one who admits you. We just have a sign up because we were getting spammers. And if you come in there, you can ask your questions. People in the community could help, or I can help. And you can learn about all kinds of different science that's going on. And I think that's all I have.
Okay, awesome. So I think Morgan is going to field any questions that any of you might have for either of our potential speakers. So if anyone
Yeah.
has any questions, so sorry, go ahead, Morgan.
No, it's fine, it's fine. What Sydney was about to say, I think, was that if anybody has any questions, now's the time to ask.
And questions can be put directly in the chat and we'll share them with our panelists there.
I'm looking at the chat and realizing I should have noticed that I did not share my screen. Oh, well.
Okay,
Well,
I did
that's
the same
fine.
thing with my presentation, so same boat.
It happens. Give it one more minute. I don't see any questions going through. And if for some reason any of you have questions later on that you didn't have time to ask at this presentation, would our speakers be okay with us sharing your emails to our participants to ask questions?
Yeah, that's fine.
Perfect. One more minute. Nothing? Okay. Do we want to move on to the explanation of the challenge now?
Yeah, I can move on then if nobody has questions. So thank you so much, Celia and Dwight, for joining us this evening. It has been a pleasure hearing Celia's insights on science communication and its importance, as well as learning from Dwight about Ocean Networks Canada and the Oceans 3.0 data portal. You truly have a vast array of data to share in so many different formats and types, so it's very cool, and we're excited to see what everyone creates with it. We truly appreciate your time and contribution to the challenge, and you're welcome to stay for the rest of the kickoff, but please feel free to leave if you need. So as Sydney mentioned previously, the overarching challenge question is how can you present data in a way that is both accessible and meaningful? But this challenge is divided into 3 streams: on the water, in the water, and around the water. And each stream highlights different data types and perspectives, inspiring creative science communication and storytelling approaches. Next slide, please, Sydney. Thank you. So the first challenge stream is on the water. Stable ocean conditions are essential for industries such as fishing, transportation, tourism, and recreation, and these form the backbone of many coastal economies. The problem is that rising sea levels, unpredictable weather patterns, and stronger storms are posing significant challenges to these industries, and shifting fish stocks due to changing water, temperatures, and ocean currents impact both commercial and indigenous fisheries. This requires new management strategies and adaptation measures. Extreme weather events pose growing threats to ports, shipping routes, and coastal tourism. This disrupts supply chains and causes infrastructure damage. Recreational activities like boating, fishing, and surfing are also affected as stronger storms and altered wave patterns reduce accessibility and increase safety risks. Next slide, please, Sydney. The second challenge stream is in the water. Canada's Pacific, Atlantic, and Arctic oceans are all undergoing major changes as rising temperatures, acidification, and oxygen loss are disrupting marine ecosystems, influencing ocean currents, threatening biodiversity, and disrupting food webs. These changes impact nutrient availability and water conditions, which influence the growth, development, and reproduction of marine species. For example, increased acidity weakens the shells of shellfish like oysters, mussels, and scallops, and leaves them more vulnerable to predation and environmental stress. Another example is dead zones, where low oxygen levels make it difficult for fish and other marine life to survive. Warming ocean temperatures are driving many marine species to migrate northward in search of cooler waters and more suitable habitats. And pollution and habitat destruction further stress these marine ecosystems and reduce the ocean's ability to recover from climate-related changes. Next slide, please. The last challenge stream is around the water. Changing ocean conditions deeply affect coastal and marine-dependent communities, reshaping livelihoods, infrastructure, and cultural identities. Rising sea levels and extreme weather events are forcing some communities to consider relocation, as coastal erosion and flooding are threatening homes, businesses, and infrastructure. In fishing-dependent regions, declining marine resources put economic pressure on families and small businesses, leading to job losses and shifts in industry dynamics. Cultural heritage and traditions tied to ocean, including indigenous knowledge, historical landmarks, and coastal tourism, they're all facing increasing threats from erosion, habitat loss, and economic decline. So as a result, social structures and economies are shifting as governments, businesses, and communities navigate these challenges of adapting to a rapidly changing marine environment. Next slide, please. Now we're going to get into the challenge rules. Next slide. So competitors must either own the rights to all software used in their project or have written permission from the owner. And if you do obtain written permission, make sure to include that in your final submission. Submissions can be as simple as an infographic or as complex as a machine learning model. We really just want you to be creative and leverage your unique skills and experiences. Competitors can participate individually or in teams of up to 5 members, and submissions must not include any confidential information. Each project must include data from the Oceans 3.0 data portal that Dwight presented, but you can supplement it with other data sources if you choose as well. Make sure that your data sources are clearly cited in your final solution or presentation. Competitors must currently live in Canada and have a Canadian bank account, and this just ensures that we can deliver the prize money to you if you win the challenge. Competitors must also be a current part-time or full-time student at a post-secondary institution in Canada or have graduated from one of these institutions in the past 12 months. So now, if you can go to the next slide, Sydney, we'll move on to the final submissions. In order to be eligible to win, every single team member must complete the team member registration form, and this is different than the Ticket Tailor registration you filled out to attend this kickoff. The team member registration form is a Google form, which you can find the link to in the challenge description document and also on the Ocean of Data page on the DeepSense website. So one team member must then submit the team concept submission form, where you give a summary of your final project and your references, all of that, and the link to your recorded video presentation. These two things are sent to info@deepsense.ca. And then if you have any additional supporting materials, you can feel free to share those as well. Like if you do an infographic and you're presenting in a video, but you also want to send us the actual infographic if it's easier to read, please do that. Next slide, please, Sydney. The final product must be presented in a video that can be shared with the judges. So in this challenge, we don't have a live presentation. We just use the recorded videos. So the video must be no longer than 3 minutes. And we want to make sure that you edit those or refilm it as needed to stay within the time limit, because we are quite strict about the 3 minutes, just so judges have enough time to review everyone's information. The video must be uploaded online, preferably as a private YouTube link, but you can use a different platform if you would prefer as well. But any videos that need to be downloaded to be viewed will not be accepted. And feel free to use any format that you like for the video. We will accept a direct pitch to the camera, a narrated slideshow, or any other kind of idea that you would come up with. If you have any questions about that, you can always reach out and we'd be happy to answer that. I know this is a lot of information for you all to take in, so don't worry, we'll be sending you all the details in an email after the kickoff event and throughout the challenge. If you have any questions about requirements or anything else, please email info@deepsense.ca. Next slide, please, Sydney. So I know many of you are probably excited about the prizes, and this year we have a total of 4 prizes that total $1,850. First place will be awarded $750, second place will be awarded $500, third place will be awarded $300, and we have a top technical design prize that will also be awarded $300. The final submissions will be assessed based on the presentation quality, as well as the clarity, creativity, and potential impact of your submission. So your submission is not just about displaying the data, it's about turning that data into a compelling story that educates, engages, and inspires, whether it be an app, an infographic, or a piece of artwork. Just focus on connecting scientific insights with real-world impact. Perfect. So now we're going to move on to the challenge schedule. So the Ocean of Data Challenge begins today with this kickoff, and you now have just over 2 weeks to brainstorm, refine, and develop your solution. By 11:59 p.m. Atlantic Standard Time on February 24th, each team member must complete the team registration form, and one member must submit the team concept form along with the link to your video presentation to us at info@deepsense.ca. And I know I mentioned this already, but I just would hate for someone to miss out on a chance to win because they didn't complete all the necessary steps. So make sure you read all the rules very carefully. And then from February 25th to March 10th, our judges will review all of the submissions and the winners will be selected. And then finally, on March 12th by 3 p.m. that day, the winners will be announced. Next slide, please. So now we will begin the challenge question and answer portion of the event. So please drop in any questions you may have in the chat. We're happy to answer any specific questions you may have about eligibility or any questions you might have about the data. Whatever you need help with, we're here to help. Doesn't look like we're getting any more questions. So if anything comes up, feel free to email us. We're always happy to help. And like I said, I will be sending out an email to everyone tomorrow morning with the link to this recording and also all of the links to all the documents that you need. And so I just want to thank you all for joining tonight, and I hope you all have a great evening.
Thank you.